student, today we start with the concept of zero vector. So what do you mean by zero vector? A vector having magnitude 0 with an arbitrary direction known as the zero vector. How can you identify a zero vector? This is the symbolical representation of zero vector. For example, whenever any object revolving in a circular path for one complete rotation, the displacement vector is a zero vector. Similarly, velocity vector is also a zero vector. After that, we start with the discussion of vector algebra. Okay, in vector algebra, we have to perform three types of operation taking the vectors. Number one, vector addition. Number two, vector subtraction. And number three, vector product. Today, we discuss about vector addition. For the addition of vectors, the normal algebraical rules is not applicable. Why? Because whenever we want to perform the addition among the vectors, vector having both magnitude and direction. That's why normal algebraical rules is not applicable. For the addition of vector, there are three different rules. Number one, triangle law of vector addition. Number two, parallelogram law of vector addition. And number three, polygon law. Among these three laws, remember one thing, triangle law and the parallelogram law are responsible for the addition of two vectors only. And the number three, polygon law is applicable for the addition of more than two vectors. So first we start with the triangle law of vector addition. Listen to me carefully the statement. Suppose you want to add two vectors, p vector and q vector. According to triangle law, you have to represent that two vector by both magnitude and direction by the two sides of a triangle taken in same order. Okay, now see, AB is a one side and BC is the another side of a triangle by which we represent the given vector p vector and q vector, and the arrow represent that they are taken in same order. They are taken in same order. So whenever two vector represented by two sides of a triangle taken in same order, then the closing side of the triangle taken in opposite order will represent the resultant vector by both magnitude and direction. That's why r vector here, which is the resultant vector, is equal p vector plus q vector. So whenever you perform the addition, one thing you have to remember, both the vector are of same nature. Means you can add force vector with force vector. You cannot add force vector with velocity vector. These things you have to remember. Now, as r is the resultant, so r vector having both magnitude and direction. So you have to determine the formula for the magnitude of r and the direction of r. To determine the magnitude of r, we take the right angle triangle ACD. Of this right angle triangle ACD, we can write according to Pythagoras theorem AC square equal AD square plus CD square. Okay, and in place of AD we can write AB plus BD. So that's why in place of AD square we can write AB plus BD whole square plus CD square. Now according to A plus B whole square formula, we can write AB square plus 2AB into BD plus BD square plus CD square. Now See another right angle triangle which is BCD. From that right angle triangle only BC known to us, BD is unknown, but here BD is required. That's why from this right angle triangle we determine the value of BD as BC cos theta. BC cos theta. So now therefore AB square plus 2AB in place of BD, BC cos theta, and from this right angle triangle again BD square plus CD square we can write BC square. BD square plus CD square is equal BC square. That's why in place of these two I write here BC square. Now put the value. AC is denoted by R, so AC square means R square. AB is P, that's why P square plus 2AB 2P. BC cos theta means Q cos theta plus BC square means Q square. So therefore R equal root over of P square plus Q square plus 2PQ cos theta. So this is the formula by which we can determine the magnitude of the resultant vectors. Now we have to determine the direction of these resultant vectors. To determine the direction, we consider an angle phi which makes by the resultant vector with P vector. And to determine the value of phi, again we take the right angle triangle ACD. Of this right angle triangle ACD, we write tan phi. So tan phi equal perpendicular CD by base AD. So CD by AD. Again in place of AD, we can write AB plus BD. So that's why CD by AB plus BD. Again CD is unknown to us, which is the perpendicular of the right angle triangle BCD. So therefore the value of this perpendicular CD is calculated over here as BC sin theta. BC sin theta. So now tan phi equal BC sin theta by AB plus BD. So what is the value of BC? BC is Q, that's why Q sin theta by AB. What is the value of AB? P plus BD. What is the value of BD? That is Q cos theta as calculated here. Okay, so now this is the formula Q sin theta by P plus Q cos theta by which we can determine the angle phi. And whenever you determine angle phi, you can say what is the direction of resultant vectors. So this is the explanation of triangle law of vector additions. Next, we move into the parallelogram law of vector addition. Before know about the parallelogram law, one thing you have to remember, whatever may be the law you used, the addition result of the two same vector remains same. Whether you use triangle law or parallelogram law, if you add the two vectors P and Q, your final result remains same. Okay. Now we explain the parallelogram law of vector addition. Okay. So what is the statement? According to parallelogram law, if the two given vector represented by both magnitude and direction by the two adjacent sides of a parallelogram, then the diagonal of the parallelogram which is drawn from their common point will represent the resultant vector by both magnitude and direction. Now see the diagram. This is the diagrammatical representation of parallelogram law. Now A, B, C, E is a parallelogram. Of this parallelogram, by the two adjacent sides AB and AE, we represent the two given vector P vector and Q vector, where theta be the angle between the two vectors. Then the diagonal which is drawn from their common point, that is from the point A, will represent the resultant vector by both magnitude and direction. That's why according to statement we can write r vector equal p vector plus q vector. So therefore here also we have to determine the magnitude of r as well as the direction of r. Okay, to determine the magnitude and direction, you remember the calculation same as the triangle law calculations. How? We know the opposite sides of a parallelogram are equal. That's why the q vector can be replaced by the side BC of the parallelogram. So that's why here I write q vector. Now you forgot about the upper portion. Now you consider ABC is a triangle where p vector, q vector taken in same order, and this are the third side of the triangle which is taken in opposite order. Therefore, we can apply the triangle law here also. Okay, so by taking the same right angle triangle ACD, we can determine the magnitude of r vector as p square plus q square plus 2pq cos theta, and the direction tan phi equal q sin theta by p plus q cos theta. These two laws are very important for your exam purpose. Now, there are some special case you have to remember. What are the special case? Number 1, whenever theta equal 0. Theta 0 means the two vectors are parallel to each other. Then the magnitude of the resultant can be written as root over of p square plus q square plus 2pq. Why? Because cos 0, 1. So according to this, we can write here p plus q whole square, with the whole square root is cancelled. That's why r equal p plus q. What is the meaning of this? Means whenever two vectors are acting in the same direction, their magnitude of the resultant can be calculated by taking the algebraical summation. Now for direction, tan phi equal 0. Why? Because sin 0, 0. So that's why tan phi 0. Now remember, tan 0 degree is 0. So what is the phi? Phi equal 0 degree. What is the meaning of that? What is the angle phi? Phi is the angle made by the resultant vector with p vector. So that's why as phi equal 0, we can say resultant vectors are also along the direction of given vectors. Now case 2. When theta equal 90 degree. 90 degree means two vectors are perpendicular to each other. Then from the magnitude formula, r equal root over of p square plus q square. Why? Because cos 90, 0. And then tan phi equal, from this formula, sin 91. That's why in the numerator there will be a q. Then in the denominator, p plus, this term will 0. So that's why tan phi equal q by p, or phi equal tan inverse q by p. This is the formula by which we can determine the direction. Now, whenever two vectors making an angle of 180 degree, what do you mean by that? Two vectors are anti-parallel. So then the resultant magnitude is given by root over of p square plus q square minus 2pq. That is p minus q. Why I put this type of sign? Because the subtraction you have to make such a way that whenever two vectors making an angle of 180 degree, you have to subtract for the magnitude of resultant the lower vector from the higher vector. And what is the direction of resultant? The direction is always along the higher magnitude vectors. So these three are the special case. Whenever you know the angle between the two vectors like 0 degree, 90 degree or 180 degree, then for resultant and direction you can apply this direct formula. No need to use this longer formula. Now after that we know about the Polygon law of vector additions, which is applicable for the addition of more than two vectors. Remember one thing, polygon law is the generalized form of triangle law. Why? Because the statement of the polygon law we can prove using the triangle law as well. What is the statement? If the given vectors represented by the different sides of an open polygon taken in same order, then the closing sides of the polygon taken in opposite order will represent the resultant vector by both magnitude and direction of the all given vectors. Now see the diagram. Here four vectors given to you: A vector, B vector, C vector and D vector. That's why we represent all the four vectors by the different sides of an open polygon taken in same order. Just see the arrow. The arrow will represent the four vectors taken in same order. Therefore, the closing sides, that is MO, which is taken in opposite order, will represent the resultant of these four given vector, that is A vector plus B vector plus C vector and D vector. This statement we can prove, as I say, using the triangle law. How? Take the first triangle MNP, where A vector, B vector taken in same order but R1 taken in opposite order. That's why using the triangle law we can write R1 vector equal A vector plus B vector. Now you forgot about A and B. Now you consider about the triangle MPQ, where R1 and C taken in same order but R2 taken in opposite order. So again, using the triangle law we can write R2 equal R1 vector plus C vector. That is R1 is A plus B, that's why A vector plus B vector plus C vector. Now you forgot about this lower portion. Now you have R2 vector and Q vector which are in same order, but this one are in opposite order. That's why from the triangle MQO, the final resultant R is equal R2 vector plus D vector. That's why I write R2 vector plus D vector, which is equal A vector plus B vector plus C vector plus D vector. So therefore, in the proof of polygon law, we use the triangle law. That's why we can say polygon law is the generalized form of triangle law. So this is all about your vector additions. Okay, read carefully. If you have any doubt, then you can call me, because this is very important portions. Thank you.